In our book, on page 234, we are going to study organic synthesis. Organic synthesis is the making of useful organic products like medicines, building materials, fuels, etc. It involves a series of steps that take us from the starting materials that are available to the desired end products. Organic synthesis reactions are very complex most of the time. They are unlike the reactions that we are used to studying that are very direct. Each individual step has a limited yield, which is the amount of product we will get. Not all the reactants will turn into products. Some reactants will remain and will not react and give us products. This means that we will almost never get 100% yield. Organic molecules are sensitive to temperature and pH. It is difficult to control these conditions at each stage because, as we said, we have multiple steps. This makes the yield decrease even more. We are going to see some examples of organic synthesis processes, specifically for some artificial sweeteners. First, we're going to talk about saccharin. It is sweeter than sucrose, which is the sugar, but it has a bitter aftertaste at high concentrations. It was used by diabetics, or patients of diabetes, as a substitute for sugar. It is an arene compound. It is a compound of the arene family, and it is called benzoic sulfonide, and its formula is C7H5NO3S. This is the molecule of saccharin. As for the manufacturing of saccharin, there are different ways to manufacture it, using anthranilic acid and successive reactions with the following: nitrous acid, sulfur dioxide, chlorine, and then ammonia. The starting material is anthranilic acid, and it reacts with these 4 steps to reach saccharin. And this is the starting material, which is the anthranilic acid. This is the saccharin, which is the end product. Another artificial sweetener is aspartame. It is still used to this day as a substitute for sugar. It is white and it is odorless. These are some of its characteristics. It does not have a bitter aftertaste like other sweeteners, as we said, like saccharin, and it cannot be used in food that is intended to be baked or cooked in the microwave because at high temperatures, aspartame decomposes. As for how to manufacture aspartame, how to make it, it is of course different from the manufacturing of saccharin. This time we need to produce 2 amino acids. They are aspartic acid and phenylalanine, and we actually use bacteria to produce them. There are L and D enantiomers of aspartic acid and of phenylalanine. They need to be separated, and only the L enantiomers are used. So here in the manufacturing process, we're going to use L phenylalanine, L aspartic acid. We're going to react them with methanol, and we will get aspartame with 2 molecules of water.